Okay, so today we're going to talk about section 1.4, quadratic equation. So we're going to let A, B, and C represent real numbers where A does not equal 0. Then a quadratic equation in the variable x is an equation in the form of ax squared plus bx plus c equals 0. We have a couple properties. We have something called the zero product property, which you're probably familiar with. It says if m times n equals 0, then either m equals 0 or n equals 0 or possibly both. Then we have a square root property, which says if x squared equals k, then x equals plus or minus the square root of k. So in this section, we'll be using the plus or minus when we take the square root. So let's look at an example of this. So solve the equation. So we have, and this is skill practice 1, and I'm looking at A. So I have y squared plus 3y equals 0. So now I can factor out y and get y times y plus 3 equals 0. Now that means either y equals 0 or y plus 3 equals 0. We can solve for y here, -3. So we can plug these values in. If y is 0, I get 0 squared, which is 0, plus 3 times 0, which is 0, equals 0. So that is definitely an answer. And here I have plugging in -3, I get -3 squared, which is 9, plus 3 times -3, which is -9 equals 0. That works as well. So my solution set is 0, -3. Okay, now we're going to learn some other methods to do this. The next method is called completing the square. So the first thing to do is divide both sides by a to make the leading coefficient 1. So remember, we're looking at y equals ax squared plus bx. Or I guess we're looking at ax squared plus bx plus c equals 0. So we divide by this a. If we're lucky, it's 1. We don't have to worry about it. Then we'll isolate the variable terms on one side of the equation. We'll complete the square. Now this is where it gets kind of funky. You add the square of 1/2 the linear term's coefficient to both sides. So we take 1/2 of b squared and add it to both sides. Oh, we skipped here, didn't we? Isolate the variable. So we're going to move this over here. Then we're going to take 1/2 b, add it to both sides. Then we'll factor the resulting perfect square trinomial, and we'll apply the square root property. Now let's look at an example of this. Now let's go with something. Oh, first, before we do that, let's use the square root property with skill practice 2. I skipped that one, sorry. So we'll just do A as well. No, let's do B, which is 2c squared plus 80 equals 0. So this is 2c squared equals -80. Divided by 2, I get c squared equals -40. So c equals plus or minus the square root of -40. Now, for this chapter and this chapter only, we will use imaginary numbers. In this case, this is plus or minus the square root of 40 times I. Because if you don't remember, I is equal to the square root of -1. And we can go further here, plus or minus. And 40 is 4 times 10. So this would be 2 times I times the square root of 10. So that would be on homework what you would have to put. Again, as I said, other than homework, we won't be dealing with this. So now let's go back. We talked about completing the square. So let's see. We'll skip to skill practice 4. And we're looking at x squared minus 2 equals 8x. Well, we're lucky. That's a 1, so we don't have to deal with dividing. That's always nice. But we need to get the variables all on one side. And then I need to get this on the other side. So I'll subtract 8x of x squared minus 8x, and this equals 2. Now, we take b. b is equal to negative 8. Then I think, what is 1/2 b? Well, that's negative 4. But what is 1/2 b squared? Well, that would be 16. So my next step here is to add that 16 to both sides. Now, the purpose of this is this magically becomes x plus 1/2 b squared, and this becomes 18. Then we use the square root property, x minus 4 equals plus or minus the square root of 18. Now we can factor that or reduce that to 3 times the square root of 2. Then we add 4. So we have x equals 4 plus or minus 3 times the square root of 2. And that would be our solution. You could leave it that way. You could write them separately. 4 plus 3 times the square root of 2, 4 minus 3 times the square root of 2. Either way will work. I'm not overly picky. Okay, so we can really skip skill practice 5 as we just did it to a degree. So next up is the biggie, quadratic formula. For a quadratic equation of the form ax squared plus bx plus c equals 0, where a does not equal 0, the solutions are x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So let's talk about this a little more before we do an example or two. Using the discriminant to determine the number and types of solutions to a quadratic equation. Again, given our quadratic equation, the discriminant is this part here under the radical. So we have 3 possibilities with our discriminant. If it's less than 0, we have 2 non-real solutions. And again, beyond chapter 1, we won't deal with that. Once we get to graphing, we will stay with real numbers only. So in that case, it would be no solutions. Now, if it's equal to 0, you have 1 real solution. And if it's greater than 0, you have 2 real solutions. So let's look at a couple of these, see what we've got. Solve the equation. I don't want to use that. So let's look at, actually, let's just look at this one. Let's take this equation here. X squared minus 2 equals 8x. So now we want to do this with the quadratic formula, which is we need it in the form ax squared plus bx plus c equals 0. And then x is equal to negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So let's get this in the right form. I have x squared minus 8x minus 2 equals 0. I'm in the right form. So now I want to find x. X is equal to negative b. So the negative of negative 8 plus or minus the square root of b squared, negative 8 squared, minus 4 times a, which is 1, times c, which is negative 2, all over 2 times a, which is 1. So what am I looking at here? I'm looking at a negative of negative 8, which is 8, plus or minus the square root of 64 plus 8 all over 2, which is 8, plus or minus the square root of 72 over 2. 72, that's what, 4 times 18? Let's think. That's 8 plus or minus the square root of 9 times 2 times 4. So 3 and 2, 6. So I have 8 plus or minus 6 times the square root of 2 over 2, which would give me 4 plus or minus 3 times the square root of 2. So the thing about the quadratic formula, as I said, it works for anything that we can put in this form. Now, depending on how good you are at factoring is probably the easiest way to do it if you see it. If you have to think about it too much, it's not the way to go. And unless you're specifically told which method to use, and I do believe the exam for this chapter does have a question that makes you use completing the square. So make sure you can use all 3 methods. And that is it for this section. Have a good day, and I will see you next time.